Let's review now this metric system of preferences. Now, these are the SI prefixes symbol. We have iota, zeta, exa, peta, and then these are the symbol. We have the mega, that's capital letter M, kilo, that's small letter K. Now, take note that for every prefixes or symbol, there is a factor power. For example, we have here 10 raised to 24 is septillion, 10 raised to 21 is sextillion, and then 10 raised to 18 is 2 quintillion, and then 10 raised to 12 is trillion. Now, we have here the SI prefixes. Instead of using trillion, we will use tera. Instead of using billion, we will use giga. That's why, let's say for example, we have 1 gigameter. We could express it as 1 gigameter is equal to 10 raised to 9 meter. Another thing, we have here 1 kilometer. We can say that is equivalent to 10 raised to 3 meter. Now, we have hecto. Take note that the 1 hectometer is equivalent to 10 raised to 2 meter, or simply 100 meters. And then 1 decameter is equivalent to, so 1 dA, or sometimes it is small letter d, and if I use decameter, dm is equivalent to 10 meters. And note that 1 meter, since it has no SI prefix, that is equivalent to 10 raised to 0 meter. And in math, what is 10 raised to 0? Any number raised to 0 is equivalent to 1. Next, how about this decimeter? 1 decimeter is equivalent to 10 raised to negative 1 meter. Take note that this 10 raised to something, is always with the base unit. Let's say for example, I have here 1 millimeter. Where is 1 millimeter? This is my 1 millimeter, and that is 10 raised to negative 3. This 10 raised to negative 3 is always with the base unit. My base unit right now is meter. Now, commonly, the students will have this erroneous writing. They will always write like this: 1 meter is equals to 10 raised to negative 3 millimeter. This is a no procedure. It will get you wrong. What I want to try to emphasize here is, for every 1 millimeter, the base unit, which is meter, will always be with the factor power, or the factor or the power. Another example, say for example, how many meters are there in 1 centimeter? So I could write 1 centimeter is equivalent to 10 raised to negative 2 meter. I want to emphasize again, this 10 raised to something is with the base unit. Now, let's continue. We have here micro, 10 raised to negative 6. That is millionth of a meter. Meaning to say 1 meter divided million times. Then therefore it is micrometer. And then nanometer, 1 meter divided in billion times. So therefore 0.000000. So how many? That's 10 raised to negative 9. Okay, and we have the pico, femto, atto, zepto, and yocto. Now, meter cannot just be the base unit. I could change this meter. I could change this into grams. If I'm talking about weight. Okay, so let's say for example, we have here uh, 1 micrograms. So we have here 1 micrograms, that is equivalent to 10 raised to, what is micro? Micro is 10 raised to negative 6. So we have 10 raised to negative 6 grams. Now, take note again that the 10 raised to something is always with a base unit. Oh, let me give another example, another base unit. This time, we will talk about computers. And usually, we use bytes. So if I have here 10, so if I have here 1 gigabyte, not 10, so it's 1. So if I have here 1 gigabyte, I could say that is equivalent to 10 raised to, what is giga? Giga is 9. So 10 raised to 9 bytes. So let me clear the page. Now, in summary, we use this metric system. It is much easier to use simply because this metric system, it uses a power factor of 10. It is much easier for us to remember. So, once again, I will going to write, if I have 1 centimeter, that is equal to 10 raised to negative 2 meter. If I have 1 decameter, that is equivalent to 10 raised to 1 meter. Now, take note, this 1 centimeter, we have this idea that 100 centimeter is equals to 1 meter. Is this concept consistent with our new concept? Yes. Simply because if we're going to study this 100 centimeter, that can be expressed as 10 raised to 2 centimeter is equals to 1 meter. Manipulating it algebraically, so if I'm going to manipulate that algebraically, that would become 1 centimeter is equals to 1 meter over 10 raised to 2. And then therefore, that 10 raised to 2, that would become this. You put it on top, that would become 1 centimeter, and that is 10 raised to negative 2 meter. So, once again, I say that this is just a prefix. If I'm going to use meter, let's say for example, I have here centimeter. Okay, so what is centimeter? I have here 1 centimeter equals to 10 raised to negative 2 meter. If it is micrometer, that is 1 micrometer, and then as our reference, that is 10 raised to negative 6 meter. If it is, let's say for example, 1 gigameter, that is 10 raised to 9 meter. Now, what if I'm going to use mass? If I'm going to use mass, let's say for example, 1 milligram, since we are using milli is something, let's go back again. Milli here is 10 raised to negative 3. So we have 1 milligrams, we have 10 raised to negative 3 grams. Another, if we have 2 kilograms, that is, sorry, not 2 kilogram, 1 kilogram. Let me erase it. So we have here 1 kilogram. That is equivalent to 10 raised to 3 grams. So, if it is mole, how about if it is mole? If it is a mole, so let's say for example, I have here 1 millimole. Okay, so let me complete the whole word. 1 millimole. 1 milli is 10 raised to negative 3, because this is milli. 10 raised to negative 3 mole. So these are my dimension. Now, another. So if I have here 1 centimole. Sounds weird, but this is how it goes. So we have 10 raised to negative 2 mole. Okay, how about we could use liters? So, if I have here 1 milliliter, by the way, milliliter, the unit for that is 1 ml. That is 1 milliliter. Then that is equivalent to 10 raised to negative 3 liters. Still, this is consistent with our definition. Why? Take note that our definition we have before that 1000 ml is equivalent to 1 liter. Now, as you can see, if we want to manipulate this algebraically, we could say that 1 ml equals to 10 raised to negative 3 liters. It is just the same as 1 ml over 10 raised to negative 3 is equivalent to liters. And then therefore, manipulating it algebraically, that would become 1 times 10 raised to 3 ml, and that is 1 liter. And then therefore, we are still consistent that 1000 ml is just equal to 1 liter, and therefore we are still consistent that 1 ml is equal to 10 raised to negative 3 liters. How about if we're going to use bytes? That's what I've said. For example, we have 1 terabyte. So 1 terabyte, TB. And what do you mean by tera? Tera, let's look at tera. Tera is 10 raised to 12. Therefore, 1 terabyte is 10 raised to 12 bytes. Okay, this time let's go directly to our sample problem. Case 2, metric to metric, 1 step. And later we have this case number 3 on the next video. So, we have here convert 200 hectometer to meter. Now, what are we going to do? The first thing that we need to do is to simply write the given. So we have here 200 hectometer. I want to convert it into meter. Now, based on my definition, I will look for my dimension. My dimension here is for every 1 hectometer, equals, let me check, hecto here, so we have here hecto, and then we have here 10 raised to 2, and then therefore 1 hectometer is 10 raised to 2 meter. Now, therefore, I can try to convert it times, which one will I put below and which one I will put on top? What is my goal? My goal is to simply cancel this hectometer. In order for me to cancel that hectometer, I will write this 1 hectometer here. Let me write it. So we have 1 hectometer and then 10 raised to 2 meter. Now, in order for me to facilitate it easily, let me convert this into scientific notation. Now, so I have here, this one is 2 times 10 raised to 2 hectometer times 10 raised to 2 meter 1 hectometer. Therefore, what will be now my final answer? So that is simply 2 times 10 raised to 2 times 10 raised to 2. Now, solving it, it will become 2 times 10. This base have, we have the same base, 10 raised to something. And then, therefore, we'll have, since that is multiplication, we have to add the exponent. That is 2 times 10, then 2 plus 2. So we have 2 times 10 raised to 4. What is the unit? Meter. And this will now be my final answer. Now, let me go now to my second step. Convert this 35 kilometer to meter. Again, we will write 35 kilometer. Then write again, my dimension. What is my dimension? My dimension here is for every 1 kilometer, that is 10 raised to 3 meter. So therefore, I could do now my dimensional analysis, 35 kilometer, and then I have here 1 kilometer because I want to cancel the unit, and then 10 raised to 3 meter on top. And then therefore, simply need to cancel the unit, and then that would be 35 times 10 raised to 3 meter. Now, I want to make it into acceptable scientific notation. That would be 3.5 times 10 raised to 4 meter. That's it. Now, number 3. Convert 0.004 decimeter to meter. So, let's do this time. First thing that we need to do, simply have this 0.004 decimeter. Now, take note, this 0.004, let me express this in scientific notation. We have here 4 times 10 raised to what? 1, 2, 3. So, we have 4 times 10 raised to negative 3 decimeter. Now, I want to convert it into meter. So, I will write here. Let me now do it. 4 times 10 raised to negative 3 decimeter times. Now, take note, my unit is decimeter to meter. What is decimeter? I will now write for every 1 decimeter is equals to 10 raised to negative 1 meter. Where do I find this? Let's again review this. This one is deci. Let me highlight it. So I have here deci. And then 10 raised to negative 1. That is tenth of a meter. So let's go back. So, again, where will I write this 1 decimeter? I will write it here, 1 decimeter. And then I will write here the 10 raised to negative 1 meter on this portion. Okay? Simply cancel it. Now, what is my final answer? My final answer here is 4 times 10 raised to negative 3 times 10 raised to negative 1. So, we have 4 times 10. Since that is multiplication, I simply need to add the exponent, and that is negative 3 plus negative 1. Negative 3 plus negative 1, and that is 4 times 10 raised to negative 4. And the unit here is meter. Then let me write my final answer. Okay, next problem. We have here, convert 0.006 meter to nanometer. So how many zeros is this? Let me write it in proper scientific notation. We have here 6 times 10 raised to 1, 2, 3, 4, 5, 6. So we have here negative 6. So I will write now 6 times 10 raised to negative 6 meter times. Okay, let me check again. What is nanometer to meter? If you look on our table, that is 1 nanometer. Let's try to go back again with our table. So we have here nano, and nano is 10 raised to negative 9. So let's go now again. 1 nanometer is equals to 10 raised to negative 9 meter. Now, let me re-emphasize that 10 raised to negative 9 must be always with the base unit. If you write it as like this, 10 raised to negative 9 nanometer is equals to 1 meter, definitely this is totally wrong. Let me re-emphasize this because most of the student would get wrong with this concept. Okay? So, let me continue. We have this R dimension. I will write my 10 raised to negative 9 meter, 10 raised to negative 9 meter, and then we have here 1 nanometer. So, let me cancel now. So, what will be my solution? That would become 6 times 10 raised to negative 6 divided by 10 raised to negative 9. Now, how do we do this? So, that would become 6 times 10 raised to negative 6 minus, remember this concept. Let's say, for example, we have a raised to m, that is a divided by a raised to n. Remember your math class, we have a raised to m minus n. For example, we have here a raised to 5 over a raised to 3. That is simply a raised to 2. Now, negative 6 minus negative 9. So therefore, what will be the answer? That is 6 times 10 negative 6 plus 9, and then therefore that would become 6 times 10 raised to 3, and the unit is nanometer. So that's it. I hope that you've learned something from this.